No, it's brilliant. Thank you very much. And yeah, it's a pleasure to be here. It's my first talk with MKAI, so I'm definitely looking forward to it. And just to quickly say, I think the previous two sessions have been like absolutely fantastic. The caliber was just paramount, I think. And I think it's taken quite a nice journey, talking about, all the way from that medicine piece that Yulia was talking about. And I think Jan summarized quite nicely that different elements and different aspects of AutoML. And I think for us, we're coming at it from a slightly different perspective, in the sense that we'll be looking at more of the, I suppose, the easy way to describe it is business accessibility of AutoML more than anything else, and how easy it is actually to use, and is it actually that useful? So not to delay too much, I know you've got plenty of content. So in terms of what we want to sort of go through, I think as a whole, I keep it relatively high level, and it really is, almost asking the what and why of AutoML. Why does it exist? What is it trying to achieve? How well does it actually do it? How do we use it as well? And then at the end, I sort of want to summarize to a point around the so what. Why should we care about that? What else can we do? And how useful is it actually going to be? And I'm conscious that the screen's probably a little bit too small on there, but hopefully the following slides will be large enough to sort of talk through. But moving on then, not to distract ourselves too much, I thought it was worth talking about this whole topic of demystifying machine learning. And as a whole, we know that data science and machine learning, AI is complex. There's a lot to it. It's not easy. And I think the fact that it's trying to be automated, I think it becomes to a point where, there's still a lot more to go. There's a long journey to go as a whole. But what this enables us to do is to really think about the reasons why that will be the case. I think the next slide kind of summarizes it. There's two core areas, I think, for the reason why this happens. And to begin with, it's very clear to see, even from the past presentation, that good machine learning models take time to develop. It's not a clear-cut thing. There's a lot of iteration, changes, feature engineering that we need to go through to actually understand what is the right way to use this data and what's the right application of that data. And even thinking about topics such as AI for good, for example, from an ethical perspective, we need to make sure we use the data in the right way and we're using the right features to be able to get the outcome that we actually want. And I think the second side of it, and it's more from a person perspective, I think. There is a stigma, especially from less technical savvy people, that data science, machine learning is a very complex area. There's a lot of unknowns, and I think people fear unknowns. I think people see it as a very high entry barrier, therefore they sort of shy away from it. But actually, there's something quite beautiful about data science and what it can achieve, because it takes data and the information that we've got within organizations or different settings to a whole nother level. And it's one of those things, it's easy enough to follow a simple tutorial online to say, oh, actually, how do we use this? How do we actually build this sort of model? But to actually apply it, I think that's a real art. It's not that simple to do. And hence why we have this idea of automation, and we see it everywhere. We see it in various different types of jobs over the years. Just thinking about some of the jobs we used to do as a community, as citizens back in the day, compared to what we do now, very different. And a good example of that is something like data entry. That process has been automated by doing and using things like forms to capture that information in the first place. And I think this is where the next slide sort of talks about this whole idea of autophobia. And it's an interesting article I read on medium.com, the website. And a lot of data scientists seem to fear this idea of automation a little bit. And that actually, what does that mean? But I thought this quote was quite nice to sort of summarize what is it that AutoML tries to do. And in a way, it's really just an assistant. It's probably the way to look at it. And knowing that actually there is other things that we can do, and there's other ways we can look at data. And I think this is part of that journey. But to sort of jump into the finer details of that, I'll let Jack sort of take us through some of the more granular sort of application of AutoML, and what is it at a finer detail as well.
Oh, brilliant, thank you very much, Paul. So I've got a slide here that says defining what AutoML is. I'm probably not going to go into too much detail in this, the privilege of going last. But I think what's worth noting, to take something from Jan's talk, is when we're talking about AutoML here, we're typically talking about end-to-end AutoML, so the whole package. Now, taking this quote off Wikipedia, I love quotes on Wikipedia. Wikipedia defines AutoML as the process of automating the process of applying machine learning to real-world problems. Bit of a mouthful, but also I think it sort of sums it up quite well. But then, talking about autophobia, what you might say is, wait a minute, hang on, isn't that what I do? I apply machine learning to solve problems. Like, what does the data scientist do? So I've sort of drawn up here probably hopefully not too offensive data science process. So at a really high level, you want to find out what the business objectives are. You want to gather requirements, to gather data. You need to explore that data, do some modeling, evaluate those models, and then deploy and monitor those models out in production as well. And in terms of what the scope for AutoML is, I would say it probably falls around this section. Now, I will accept there's definitely a bit of grey area on data acquisition and exploratory analysis. Different AutoML tools out there will do different things, and it can be a bit of a blurred line. But you can see that does cover a lot of what you might consider to be the typical data science role. And I do believe that, again, back to Paul's point, it's an assistant role, right? There's a lot more to data science than just building ML models. And if you can cut out actually the process of building those models and testing, oh, what if I use this sort of algorithm or that sort of algorithm, or this hyperparameter or that one, you've saved a whole load of time. And as well, deployment and monitoring, they're fast to set up, right? You don't get into data science to write production code. It's not, well, you probably do, but you don't get into it to sit there writing APIs all day. You want to do the machine learning and the problem solving. And what AutoML can allow us to do in a lot of cases now is actually take a lot of that out of the data scientist's hands as well. I think it sort of keys in nicely to a blog that I've wrote recently, to a bit of self-promotion. Actually, there's a lot of facets to what it means to be a data scientist. And I personally quite like this sort of three-tiered approach, that you've got maths and stats, you've got actually the business context, and you've also got actually how do you realize this on a computer in a technical aspect as well. And you can see that machine learning is that crossover there between the maths and stats and the computer science, but it's far from the whole picture of what it means to be a data scientist and what it means to do data science. So I'm going to demo a demo now. So I'm going to show you actually a AutoML platform in practice that you could go away and use today. So caveat, there's a lot of tools on the market. At the risk of sounding like a Microsoft salesman, I'm going to choose Azure Machine Learning and show you that one. So Azure Machine Learning is great because you can all go, and I do encourage you to go away and actually get a trial Microsoft subscription, and you can go in, you can do AutoML yourself and really try it out and see what potentially could help your business. So this is the Microsoft Azure portal. If you want to go and create an Azure Machine Learning instance, it's as simple as going, create a new resource, searching for machine learning, create it, and then you end up with this. You can launch your workspace and it looks something like this. So in here, you can see it can do all sorts. You can set up data pipelines, you can do experiments, it's got AutoML, it's got drag and drop low code functionality. And what I'm going to take you through first is a tutorial which I went through to learn this. It's one provided by Microsoft. If you want to take a screenshot, grab this right now. I would recommend this tutorial. It's really good. It's to go in and to work out the number of people who might rent a bike on a particular day. So essentially, you've got a data set where your target feature is how many bikes were rented, and you've got a bunch of other features like what was the weather, what was the day of the week, things like that can help us to predict how many bikes might be rented on any given day. And long story short, you can go through and you load in the data set that Microsoft provide, and you get something like this. It's gone away and it's decided, right, you have to tell it it's a regression problem, but it's decided, right, okay, I'm going to use this sort of regression. And here you go. Here are all my performance metrics. You can see down there, there's a chart of predicted versus true. and you've got something which does cling quite nicely to that sort of diagonal line up the center of the graph, which is exactly what you want to be able to see. Another great thing about Azure Machine Learning is it does have an explainable AI sort of element to it. So you can go move over to the explanations tab, and you can actually have a look at what the most important features are on how many people are going to rent a bike on any particular day. As you can see, unsurprisingly, the two most popular important features there are, was it a working day, and what was the temperature. But that's all well and good. Of course it works. Microsoft provided us that data set and they put it in their own tutorial. No big surprises there. AutoML performs great on it. What about something which Microsoft haven't tailored for this problem? So I'm going to go over the car prices problem. So this is something which, if you attended the MKI workshop last month, you'd have seen my colleagues Tajame and James solving this problem, which is a car prices model. So they used a data set from Kaggle, where there was a list of cars that were for sale, I think in Germany. And it was how much was the car sold for, or listed for, I believe it was the list price, and a bunch of features about that car. So what color was it? What make and model was it? How many doors did it have? What was its mileage? Things like that. And as you can see here on the side, I've got a snippet of James's notebook, which you can get to, again, using that QR code if you want to take a screenshot. There's also a link to the video. And he's got an R² there that's come out at 0.882. So R² score, for those who aren't familiar, is sort of a measure of goodness for how good your machine learning model is, 1 being perfect. So you can see that 0.882 is a pretty good model, and we've got predicted versus actual there as a graph as well, and you can see it is clinging onto that diagonal line up the middle, which is exactly what we want to be seeing. If you go and watch, just to explain how James and Tajame did this, it took them an hour. So this is a pretty involved thing that you needed actually data scientists and data engineering experts to work out. I'm going to take you through at a high level what they did. So they trimmed their outliers, cleaned up the data set. A lot of the cars didn't have values for every field. So in order not to just throw away all of those rows, we did something called imputation, which is where you take those missing fields and you put in sensible figures to fill them, which means that you can then run model on them regardless. And although that data is missing because you filled it in with something sensible, you're not actually going to throw the model off whack too much, and it generally helps. Another big thing they did was they rescaled the data. The behavior of the price curve was actually logarithmic. So the first pass they went through when they tried to use their linear regression model was they found that, this is awful. And that's because the data they're trying to fit to wasn't linear, it was logarithmic. So they rescaled the data. To help with that, they did things like encoding. So there's a lot of categorical variables like manufacturer. So where you want to use something called one-hot encoding to bring those out into different columns. And they also did some smart things like generated new sensible features. So 2 of the columns in that data set were price list, date listed, and date removed. So you can generate a feature from that, which is how long was the car up there for? What was the time difference between that? That's how they got through to this 0.882 R². So obviously, big question while we're here. I uploaded that data set to Azure ML, stuck it in. I didn't do anything fancy. I just said these are the columns, these are the data types. Off you go. Give me a regression model. How are you going to get on? It didn't go on very well. As you can see there, although for the very low values, the data does stick to that diagonal line, it very rapidly decreased, sort of tapers off there. And you can see that the R² score, which is up on the screen there, is basically 0. So this is not a good model, it took me a bit by surprise. I was like, oh, why is AutoML not working here? What have I missed? So I thought, okay, well, let's do a little bit of thinking. Let's bring a little bit of data science expertise into this. And what I did was I said yikes first, but I went in and I said, okay, well, the first step that James and Tajame did was they logged the price of the cars, and they built a model on the logarithm of the price rather than the actual price. So I thought, okay, let's do that. The great thing about it was I could do that in Azure Machine Learning as well. This is why I sound like a salesman. It's also got this lovely experiments tab, which is kind of like your low code ML stuff. And I could say, okay, take my data set, let's apply a mathematical operation, natural logarithm, and let's export that back out as a new data set that we can now train the model on. And that was really easy to do up in there, but it required my data science expertise to know that that was a sensible thing to do. But running that through the AutoML this time, just doing one single piece of data engineering there to get us to this point, and the model's much better. You can see there we've got an R-squared score of 0.7, which is very competitive. So for context, when James and Shane did this, just by doing the log, they were having a model with an R-squared of about 0.56. So this is a significant improvement for a considerable amount less effort. It's obviously not reached the dizzy heights of where they got to with their final data engineering, but it's gone a lot of the way there for a fraction of the amount of effort, which I think is really where AutoML can shine. And I think, sure, if I'd sat down with this longer and introduced a few more of the data engineering techniques that James and Tashem had done, then I'd probably be able to push this R-squared score up even higher, perhaps to the dizzy heights of 0.9 or something silly like that. And of course, one of the great things that this allows us to do at the click of a button, which obviously James and Shane weren't able to do, was immediately have an explanation of what the most important features in the data set are. And I do think like platforms like this, like Microsoft Azure, they allow us to link that explainable AI in with the AutoML, and I think that's a real opportunity to demystify machine learning. Like, I think there's been a lot of chat about considering AutoML as a black box. I think it is, but it's also an opportunity to, if you use the right platform and we implement AutoML in the right way, it can automate that explanation and actually make AI much more accessible and clear. If you're interested, the most important feature there is mileage, which probably shouldn't come as a huge surprise, quickly followed by manufacturer. Or manufacturer year, sorry, so that's car age, effectively. So now I've got my model. How do I deploy it? Like ordinarily, I'd have to go away and I'd have to talk to my development team and I'd have to, redo it, maybe recode it in something else, or do a whole load of unit testing and things like this. You still have to do all of that, of course, but as a data scientist, the involvement is much lower because I've got this lovely button up here which says deploy. If I click that deploy button, I get this lovely little bar that comes up here, and I can deploy my model to an Azure container instance. And what that's going to do is that's going to spin up the model that I've trained. I'm happy with the metrics. I think it's an accurate model. And it's going to set that up as a REST API for me. And it'll end up looking something like this. So I've got my endpoint there, and you can see I've got a little link. Take that. What Azure ML's also done for me is it's come up and it's given me this wonderful documentation. So Swagger is a standard sort of documentation format for APIs. It's come out and it's automatically given me a Swagger documentation for my AI, for my API. And then I've gone away and I've done a little bit of coding in Python on my computer, followed the documentation, and I've got a quick little Python script here, which calls my API, which I'm hosted in Azure, generated by AutoML. I could say, this is my car, I've got an Audi A1, this is its mileage, there's a bunch of other information about it. It says, okay, there you go, sir, your car is worth 5,000 euros, just like that. That would be another huge chunk of development time if we didn't have the ability to just click that button and automatically spin it up, which I think is a real advantage of AutoML, just for the consistency it brings. So I think I probably touched on some of these already, but is AutoML a suitable alternative? So I'm going to go over and have a look at actually what I would say are some of the strengths and weaknesses of AutoML. So in terms of strengths, it's going to select your model for you, which is great. It's going to do your hyperparameter tuning, model hosting, which is a huge thing because it's actually taking that whole chunk of work and just making it a click of a button. It's going to help you with your performance monitoring. So now I've got that API up there. I can monitor it and see how it's doing, see how accurate the model is, see if it's degrading over time. It's got explainable AI built into it, or it can have explainable AI built into it, depending on what service you're using. And it's going to bring along a sense of consistency. And importantly as well, data security. So all of what I just did happened within the Microsoft Azure platform. It's all happened in the cloud, and your data security team have got control over that. So actually, I wouldn't say, some might say it's a loss of freedom, but what it allows you to do is a more consistent way of doing data science in a way that you know you're being safe and you're following the rules. You could train an AutoML model on some data that you might consider to be sensitive without ever looking at the data. There are weaknesses, of course. So these are things which I think AutoML is not great at the moment. But if you look at the trajectory and where it's going, so it's great at feature selection. So it's not great at feature selection. It's not going to know instantly which features it should and shouldn't use. It's going to intelligently generate features. It can't intelligently generate features at the moment. So think about the time posted example. The AutoML didn't know, oh, I've got these two dates, okay, let's subtract one from the other, and this time difference is going to be useful. And it doesn't really do unsupervised learning, at least not in many of the offerings. I do think this is something which is rapidly growing, but obviously getting human interaction out of unsupervised learning is very difficult. I know these limitations, I know there's some smart people on the call, so please do challenge me. But in terms of limitations, I don't think we're ever going to get business context. It's not going to do your data engineering for you. You still have to get the data up there into the platform. It's not going to know if you're providing it post hoc information by accident. So post hoc information being information which you would only know after the outcome you're trying to predict. If you accidentally pass that into a machine learning model, it can make your model look really good. But when you run it in practice, you're never going to get that information. So your model's going to be awful. And of course, goes without saying, non-machine learning models can't be done using AutoML. And there's a lot of data science out there which isn't necessarily machine learning. And what is a risk of AutoML is because it opens the floodgates, it says it makes ML so easy, you run the risk of choosing to do machine learning everything, even when it's not the most appropriate technology to use. I do apologize, Paul, I've sort of lagged on there, but
yeah, I've literally got a minute, so I'm going to try and rattle through this as quickly as possible. Apologies if I overrun a little bit there. But yes, we talked about AutoML from like a data science perspective. I think Jack's explained that at a very good level there. But it also poses a question of the earlier comment I made around actually what about other people, people that don't necessarily or are not data scientists at the moment, and what is it that they can do? And I think it depends on how we look at it. And there's a certain level of automations, and using Microsoft as the prime example in this particular talk, if we go on to the next slide, we'll talk about specifically Power BI actually. And that whole process that Jack was talking about actually is achievable within something like Power BI. You provide the data, you test it, you run an initial model, you prime the elements at the end, and then you move it forward and see what can be done. And in the interest of time, I'll skip over a little bit more about that. But with AutoML, if you think about what it is, it's the process of automation of certain elements of the workflow. And I think the next few slides sort of start to cover that in a little bit more detail. And what other options are there, for less data technical savvy people? If we skip that slide, Jack, move on straight into that one. So machine learning libraries, as a good example, using something like Azure ML, not necessarily from an auto perspective, but actually something that was bespoke and created by data scientists. It enables people to share, models that already exist in a data science perspective, and make it accessible for something like Power BI, for example, to be able to connect to, use, and apply it. And the data scientist, then the role sort of changes. You enable automation for other people, and you have that duty of care to express what it is. Q&A as the next piece, looking at actually, again, it's an element of automation in itself of what it is, but actually it's more of a pure business person asking questions, just like you would on Google. What does my forecast look like, or what is this? How does this look like? And you start to interact with it. The limitation, unfortunately, is that it only is as good as it knows. It indexes data. The data needs to be of good quality to be able to do that. But the business context is there. Going back to what Jack was saying earlier, that's a key element of when we talk about data science as a whole. I'll skip these examples in the interest of time.
They're very cool. It's a plain English question.
Yeah, yeah. Basically, at a very high level, showing the question there on the screen. Interestingly, the bronze card came out the highest average price. Going on to the next slides, the follow-up question will be something like, "Oh, what car, what make and model are bronze cars?" And you get the standard stuff, but then actually stuff like Hummer, Jaguar, which tend to be more expensive. Point 3. Auto insights, quite a big chunk of the data scientist work is obviously based around identifying distributions, trends, and also understanding where the outliers are. And I think something like that helps. And it's an automated process again, automated data science, I think I'll call it in this particular instance. And enables you to drill into some of those key areas. And then the last and final bit, because I'm conscious of time, is basic collaboration. In a way to summarize, actually think about what automation is automating on a certain process, and it doesn't necessarily need to be a machine that automates it. It could be a person that automates it for you. So this is where it comes in, having a data scientist, a visualization, a BA and data engineer to work together to achieve one certain outcome. I'll stop talking now, because I'm sure Jessel wants to.
Yes, I'm really sorry to interrupt that.
Sorry.
Absolutely, in the interest of time and looking at other speakers, I have to interrupt you.
Absolutely.
I think it was a brilliant talk. It absolutely tells us that AutoML needs to be embraced. There's a lot of fear that people have, and they don't need to have that as beginners, even though, data scientists are never going to get redundant, I think. And it is becoming so ubiquitous. I think it's everywhere. AutoML can be heard everywhere. And thinking that data science is like a magical box and we are demystifying it, it is something which took my soul away. I think this is really interesting, and people should try out the tutorials, start learning more about AutoML, and have no fears. I do understand there are people who want to go into statistics and the actual part of data science, which will always remain true. But there's a lot of things that people can learn using APIs, libraries, which are readily available free of cost, and using data from Kaggle. I think that is brilliant what we came to know today. So I'm really thankful to you, Jack and Paul.